All right, guys, Mr. Antonucci here, and we are in the second part of our videos on section 6.5, the indefinite integral and method of substitution. So in this video, we're going to cover the learning target I can use properties of indefinite integrals. Now, since the definite integral and the indefinite integral are closely related, the properties are going to be very similar to those of definite integrals. So one of the first things that's important is the derivative of a indefinite integral. So this basically says that if you take the derivative of an indefinite integral with respect to x, you will get the function inside. Because remember, integrating is essentially taking the antiderivative, and if this is saying take the derivative of the antiderivative, then you're going to be back where you started. So for this first one, the derivative of the integral is square root x squared plus 1. You probably guessed it is going to be x squared plus 1. The derivative of e to the t cosine t is going to be e to the t cosine t. Okay. Now we're going to look at a couple more properties here real quick, and then get into some more examples here. The indefinite integral of the sum of two functions. Basically, if you have two functions being added, you can take their indefinite integrals separately and add the answers. Same thing works with subtraction here. And then if you have a constant times a function, well, you can factor that constant out. Okay. Now, here we have a couple examples where we're going to use the properties of indefinite integrals. So this is kind of like an intuitive type of process, and I'm going to break it all down for you. But then whenever you actually do these by hand, you're probably not going to show as many steps. But first off, using the sum rule, you can rewrite this one as 2x to the 1/3 dx plus integral 5x to the negative 1 dx. And then using the constant multiple rule, I can write that as 2 integral x to the 1/3 plus 5 integral x to the negative 1, or 1 over x dx, like that. Okay. Now, this is going to be 2 times the antiderivative of x to the 1/3, which is 4/3 times 3/4, plus 5 times the natural log absolute value of x plus c. Now you don't have to put a plus c on the first integral and the second one because you're going to add them together. You just need 1 plus c at the end. Okay, so the 2 and the 4 are going to cancel, and then our final answer is going to be 3/2 x to the 4/3 plus 5 natural log absolute value of x. Don't forget the plus c there. Okay. The next one, I'm going to kind of do it a little bit quicker. So we can break this up into two integrals and factor out the constant of 12 from the first one. So this would be 1 over x to the 5th dx plus integral 1 over square root x dx. Now I'm going to rewrite both of those integrands. The first one I'm going to write as x to the negative 1, or the negative 5th dx. Okay, because I want to be able to use the power rule. And then the second one, remember the square root of x equals x to the 1/2. But since it's in the denominator, I'm going to rewrite it as x to the negative 1/2. So the new exponent here is going to be negative 4. And then that is going to divide by negative 4, but this is still multiplying that 12 right there. Plus x to the negative 1/2, add 1, you would have 1/2. The reciprocal is 2. Don't forget your plus c. All right. So 2 times the negative 1/4 would give us negative 3, and that would be over x to the 4th, plus 2, x to the 1/2 is the same as square root x plus c. Okay. So not too shabby there. Um, let's look at another example. I want to just do one extra one right over here. If I had the integral of 4 over x squared plus 2 over square root 1 minus x squared dx, I could rewrite that as 4 times the integral of x to the negative 2 plus 2 times the integral 1 over 1 minus x squared dx. Now, x to the negative 2, the antiderivative would be x to the 1 over negative 1, and this is going to multiply the 4 plus 2. Now, this integral, you might be stumped at first, but remember, that's the form for the derivative of arcsine. So the antiderivative of 1 over square root 1 minus x squared is arcsine, or sine inverse. And then we need our plus c. So our final answer would be negative 4 over x plus 2 arcsine x plus c. Alrighty, so let's look at one more example here, and this is going to use some more of the properties here. Now, notice the numerator and denominator are almost the same exact thing. This would be an improper rational expression, so we could do division of polynomials. So like x to the x squared plus 0x plus 6, and we net placeholder for the x term, for the linear term. And we would have to put a 1 here, so 1 times x squared plus 1 is x squared plus 1. If we subtract those, we would have 5, so the remainder of 5. This integral would be 1 plus 5 over x squared plus 1 dx. Now, another way that I've seen this done is, since the numerator contains a plus 6, and I could rewrite that plus 6 as plus 1 plus 5, then I get a piece of the numerator that's the same as the denominator, and I can break it up into x squared plus 1 over x squared plus 1 plus 5 over x squared plus 1 dx. All right, and then this is just equal to 1, and then we're back to what we have over here. Okay, so we could rewrite that as the integral of 1 dx plus 5 times the integral of 1 over x squared plus 1. And the antiderivative of 1 is x plus 5 times this 1 over x squared plus 1 is the derivative of tangent inverse, or arctan. So the antiderivative of 1 over x squared plus 1 is tangent inverse, or arctan. Doesn't matter which one you use. Then you need a plus c. Okay. So there we go. Hope that one was helpful to you guys. Take care.